Okay, a relation is a set of ordered pairs that can be represented in multiple different ways. Okay, and then a function.
How did it get to Unit 2?
Do what?
How did it get to Unit 2 packet? Only get to Unit 1.
No, keep that one. That's yours. What doesn't matter.
Okay, a function is a relation in which every domain value, which are your x values, is paired with exactly one range value, which are your y values. So that's like the super wordy definition of what a function is. Okay, every domain value is paired with exactly one range value. What that essentially means? No repeat x's. You can't have repeated x's. Okay? If an x repeats, you are not a function, you are just a relation. Okay? Today we're going to look at two different types of graphs. Okay? The first type of graph is a discrete graph. A discrete graph is a graph where the points are not connected. So we think discrete dots. They're just dots on your graph. Okay, they are not connected points. They're just dots. Okay, discrete dots. And then the way that you determine your discrete graph, the way you tell if it is a function or not, is you are going to use the vertical line test. And look for repeated x's. Have y'all done the vertical line test before? Yes, I think that's nothing new, right? If you haven't, we're going over it again today, so you're okay. Okay, so what we are stressing today is how do you determine the domain and the range, okay? In order to determine the domain and range, we need to know what that vocabulary domain means, and we need to know what the vocabulary word range means. Okay, so domain is all of the x values. And the way that we write our domain for a discrete graph is you list out the first coordinates which are your x's, of the relation. And what I say is small to big, no repeat. So there's a correct order that you put your domain in. It's small to big, smallest number to biggest number, least to greatest. And you don't repeat values. Okay, so if you have two x values that are 3, you would only write 3 in your domain once. You wouldn't write it twice. Okay? So if your domain is all of the x's, what do you think your range is? All of the y's. So your range is all of the y's. And you also list out the, we wouldn't say first coordinates because your y's are your second coordinates. Of the relation. And we follow the same rule. Small to big, no repeat. Okay, so we list them and we go small to big, no repeat. List our domain, small to big, no repeat. Those are the main things you need to remember. Domain is x, range is y. Okay? Like I said, this unit is very heavy on vocabulary. The mathing that we have to do in this unit, not super difficult. It's the vocabulary. Okay, so a lot of times students get confused or forget which one's domain, which one's range. Okay, so up at the top, I'm going to show you a little way that I like to remember. Domain comes in the alphabet, or D comes in the alphabet before R, right? Think of alphabetical order. D is before R in the alphabet. Then we have our X and Y. Which one comes first? X comes before Y. Okay? Domain goes in alphabetical order, domain, then range, D, then R, X comes first, then Y. That means my domain is my X values and my range are my Y values. Okay, this is something that might help us because you have to know your vocabulary for this unit. Domain is X, range is Y. And actually this is going to be going on through the whole year. We awake, Bailey? Yeah? Okay. So let's look at these graphs. We're going to do 3 things. We're going to say, is the relation a function? And then we're going to state the domain, which are your x's. Then we're going to state the range, which are your y's. Okay. Well, it's super hard to look at a graph and write out your x values. Okay? Because I just see a bunch of dots. I don't see any actual values. So anytime you're given, what kind of graph is this if it's just dots? Discrete. If you're given a discrete graph, write out the ordered pairs of your points. Okay? So looking at this ordered pair, looking at this point, what is the ordered pair? I go left 5, so -5, then I go up 1. So this ordered pair would be -5, 1. Okay, this next ordered pair, 1, 2, 3 to the left, 1, 2 down. So this would be -3, -2. This point right here has an ordered pair of 1, 2 to the left, which is -2, 1, 2, 3, 4, 5. So -2, -5. Are we all okay with how I'm writing my ordered pairs? Remember, x goes before y when you do your ordered pairs. If you go to the left, your x is negative. If you go to the right, your x is positive. If you go up, your y is positive. If you go down, your y is negative. Okay? What about this one? 0 what? That's the origin, 0, 0. Okay? Then go right 2, up 2. So this is 2, 2. 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6 up. So 4, 6. 1, 2, 3, 4, 5 to the right. And 2 down. So 5, negative 2. Okay, so when we are determining whether something is a function, what do we look at? Or repeated x's, okay? So let's look at our x values. Negative 5, negative 3, negative 2, 0, positive 2, positive 4, positive 5. Are any of those values the same? No. So if it doesn't have repeated x values, is it a function? You're not a function if you have a repeated x value. If you don't have repeated x values, then you are a function. So is this one a function? Yes, because there's no repeated x's. Okay. How do we write our domain and range for a discrete graph? Domain, small to big, no repeat values. Okay, so we use something that is a set symbol. It's called a curly bracket. Okay, I'm a bad curly bracketer. Okay, when you're making your curly bracket or your set symbol, you just need to make sure it's not a parenthesis. Okay, so it's kind of like a backwards 3. Okay, don't stress about making your curly bracket. Make sure it's not a parenthesis. Okay, let's see if we actually have any typed up. If you look, you don't need to turn, just look at mine. That's an example of a curly bracket. Okay, so that's what it's supposed to look like. Does mine look like that? Not really. Okay, so domain is x. I want us to get in the habit. Anytime we see domain, I want you to put an x above it. That's going to help us learn our vocabulary and make us not make as many mistakes. So we're going to look at our x values. What's my smallest x value? Negative 5. I'm underlining them as I go to know that I already wrote that x value out. What's my next smallest x value? Negative 3. Then, and then we close our set symbol. So another curly bracket, but now going the other way. So what this is saying is all of my x values for this function, or the only x values I have for this function, are negative 5, negative 3, negative 2, 0, 2, 4, 5. Okay? Now let's look at our range values. What variables range? Y. Put a y above it. We're also doing a set symbol. You use your set symbol when you are listing out your values. Okay, what's my smallest y value? So we're starting at the bottom, right? And I'm circling them as I go. I underlined my x's, my domain values. Now I'm circling my y's, my range values. What's my next one? Negative 2. I have negative 2 twice. Do I write negative 2 twice? No, I just write it once. No repeated values. Okay, don't repeat the values. What's next? 0. Then 1. Then 2. Then 6. Good? Small to big, no repeat. Is it okay that I had a repeated y value? Yes. Your y values don't determine whether you're a function or not, just the x values. If your x values repeat, you are not a function. If your x values don't repeat, then you are a function. If your x values do repeat, then you are not a function. Doesn't say anything about the y values. Okay? We good with that one? Not too bad, right? Biggest mistakes people make is they just look at the points on your coordinate plane and they just try to list out the domain and range, and then you make a bunch of mistakes. Please make sure that you don't skip this step of actually writing the ordered pairs out. Okay? Okay, next one. What kind of graph is this, guys? Discrete, because it's just dots. Okay? So let's write our ordered pairs. What's this top ordered pair?
-2, 7.
-2, 7. What about this next one?
1, 2.
1, 2. What about that one? We sometimes struggle when we're on the axes. -5, 0. Remember, your x value is your side-to-side movement. The y value is your up and down. So we went left 5, but we didn't go up or down at all. Okay, what about that ordered pair? -3, -2. Very good. And this one? 1, -5. Okay, so let's first determine if we are a function. We are looking at our x values. -5, -2, -3, 1, 1. Do I have repeated x values? Yes. Is it okay to have repeated x values? No. So am I a function? No. And I'm going to say x equals 1 twice. You're not going to have to put necessarily the reason, but on our notes I'm wanting to put the reason just so we see why did we write no. We wrote no because we have an x value that's repeated. X is 1 twice. Okay? Since it is discrete, we are listing out our domain. Domain's what variable? X. Use your curly bracket, your set symbol. We go small to big, no repeat. What's my smallest x value? -5, then -3, then -2, then 1. We have 1 twice. Do I write 1 twice? No, you don't repeat. Just once. Okay? Range is what variable? Y. So do your set bracket, set symbol, curly bracket. What's my smallest y value? -5, then -2, then 0, then 2, then 7, curly bracket. Good? Okay, now we are going to go to a different type of graph. Okay? Different type of function. What is a continuous graph? If a discrete graph is dots, what do you think we're going to do with those dots to then get a continuous function? Connect them. Think continue, connect. So a continuous graph is a graph where the points are connected. Continue, connect, discrete dots, continue, connect. Okay? Why is it important to know which one you have? We write our continuous domain and range way differently than we write our discrete domain and range. So that's why it's important to know which one you have, discrete or continuous. Okay? The way that we are going to determine if a continuous graph is a function is we are going to use the vertical line test. And I say that's the VL test. Okay? When we do our domain and range, which again, domain is what variable? When we do our domain and range for continuous functions, we're not going to list out values, because when we list it out, we're saying it just exists at those values. If it's connected, it exists from a starting point all the way to a stopping point. So it exists everywhere between two values. Okay, so that's why we can't list it out when it's continuous. Okay, so the way we determine our domain is we choose the smallest x value. Then we're going to use our less than sign, because all of our small numbers are going to be less than. We're going to use x, because domain is x, less than. What do you think is going to go over here if we go small to big? So the largest x value. So again, we're still doing domain small to big. It's just now we're not listing it out. We're using these inequality signs because we're saying our domain is every value between the smallest value and the largest value. Okay? When we have these inequality signs, what can we sometimes have under them? The equal to. So they're going to be less than or less than or equal to symbols. Okay? Okay, when we do our range is what variable? Y. We're following the same exact setup because we do range also from what number? Smallest number to the biggest number. So we're going to choose the smallest y value less than, we're not going to put x in the middle because if we're doing range is y. Less than the largest y value. And just like with our domain, what can we also sometimes have with our inequality signs? Equal to's. Okay? So again, when you have a continuous graph, you do not list out the values. You tell me the smallest, and then you go all the way and you tell me the largest. If we're doing x values, x is side to side, right? That's your side to side axis, your horizontal axis. If we're doing the smallest x value, the smallest will be all on the, think of a number line. Small numbers are on the left, and then the large numbers on the right. So when we do our domain, our x, we're going to look at the farthest to the left and the farthest to the right. When we're doing range is your y, which is your vertical. When we're doing our vertical, where would the small number be found? On the top or bottom? The bottom. So we would go bottom to top. Okay? So what we do is we basically frame in this picture. Okay? First of all, is this graph a function? Does it pass the vertical line test? Yes. Now the reason that is, guys, if I draw a vertical line, it hits the graph once. Vertical line hits the graph once. Is there any vertical line you can draw on this graph where it hits my graph more than once? And when we use the word graph, we're talking about what is graph on the coordinate plane. Okay? So that's why, yes, this is a function. I'm going to put passes vertical line test. Okay? Okay, so my domain is x. If it is continuous, because this is connected, that first point and that last point are connected, we are going to use our inequalities. Okay, so we need to find the furthest to the left. So go along your line. Here's the furthest to the left. I'm going to draw a line on the left. Well, where does that line I just drew hit the x-axis? -4. So I'm going to put a -4 up there. Now we need to find the largest x value. So go all the way to the right. Here's the furthest to the right point. Draw a line on the right. Where's that hit the x-axis? At 1. So if I cover up the left, cover up the right. Do we agree that my whole graph exists in between those two lines? Yes. So that's why it exists from -4 to +1. Okay, so now that I know my starting value, my small value, and my ending value, my large value, now we're ready to write our inequality for our domain. Again, we always go small to big. Negative 4 is less than, what variable do we use if we're doing domain? X less than, what's the large one? 1. Okay, so that's saying all of my x's are in between negative 4 and 1. Now let's talk about if we should put equal to's under our inequalities. Okay? These are two separate inequalities, so it's not like if I put one here, I have to put one there. Or if I can't put one here, I can't put one there. They're separate inequalities, so sometimes you're going to have neither of them underlined, sometimes both are going to be underlined, sometimes just one's going to be underlined for an equal to. So let's look at this dot at the negative 4. Is that dot filled in? Yeah, so this is tying into what we did last unit. If you have a filled in dot, what does that mean? It's equal to it. You include it. So put a line under the negative 4 inequality. What kind of dot do I have at 1? So what should I put with the 1 inequality? Equal to. Okay. Now let's do our range. Range is y, which is your up and down. So I need to find the bottom. So, here's the bottom point. Draw a line at the bottom. Where does that hit the y-axis? At what? Negative 2. There we go. Find the top. Here's the top. Where does it hit the top? 1. Remember, you always go small to big. So bottom to top. So I'm going to do negative 2 is less than y is less than 1. Can you ever have greater than signs when I'm doing it this way? No, because aren't all small numbers less than the big number? Yes, so both of these will always be less than signs. Okay? What kind of dot do I have at negative 2? So I put the, what kind of dot do I have at 1? Put the equal to. Okay? We good? Okay, next one. Is this a function? No, who said no? Good job, why? If I draw a vertical line right here, it touches 1, 2, 3 places. So is that a function? No, that means x is the same value 3 times. You can't have repeated x's. So no, and I'm going to say fails. VL test, vertical line test. Just because it's a function, it is still continuous because your points are connected. So we're still doing our domain and range using our inequalities. So let's look at our domain. Domain's what variable? X. Okay, so x is your side to side. So draw a line on the left. So where's the furthest to the left? Tell me where I'm going to draw my line, guys. Right there, right? None of my graph exists to the left of that line, meaning that's the furthest to the left point. Well, this hits the x-axis at what value? 0. Then where's my furthest to the right? Right there, at 4. It hits the x value at 4. The x-axis, sorry, at 4. So this is 0 is less than x is less than 4. Now we need to determine if we should put equal to's. What kind of dot do I have at 1? Sorry, at 0? Open. Do I put an equal to then on my 0 inequality? No. What kind of dot do I have at 4? So do I put an equal to? Yes. So is it okay to have one without an equal to and one with? Yes. Okay. Now let's do our range. Range is y, which is up and down. Find the bottom. Where does that hit the y-axis? Negative 4. There's the top. Where does it hit the y-axis? positive 4. Okay? So negative 4 is less than y is less than 4. Small to big. What dot do I have at negative 4? Closed. So what should I put at my negative 4 inequality? Equal to. What about at 4? Open. So do I put the equal to on the 4 inequality? No. Done. Okay. After doing 2 of those, how are we feeling about these? These are harder than just listing out the values. So the discrete ones, I think they're a little bit harder. Okay. But are we doing okay? Okay. Now we're going to get on to 2 that are slightly different. Okay. This third one. Is this a function? Why? Perfect. Yes. Because it passes the vertical line test. There's no vertical line you can draw where it hits the graph in more than one spot. Okay? So to find my domain, what kind of graph is this? Is it connected or dots? Remember, discrete is if it's just dots. This has a connected figure. We have a dot and we go that way. So this is continuous. Okay? So, to find my domain, I need to go all the way to 2, 2, 2. Okay, goes right here. But what do I see, guys? So does it really stop there? No. Anytime you see an arrow, and that's your stopping point, it's not really stopping there. So it goes on forever. What do we think I should put there? It goes on forever. Who said that? Good job. Goes on forever, we're putting in infinity. Now there's 2 kinds of infinities. A negative infinity or a positive infinity. If this is going to the left, what kind of numbers are to the left? So it's not a positive infinity, it's a negative infinity. So anytime you see a arrow, you know it's going to be infinity. Then you need to think, is it a positive or a negative infinity? Okay? Now let's go to the right. And it stops where? At 4. So small to big. Negative infinity is less than x is less than 4. Now guys, can you ever actually reach an infinity or a negative infinity? No, it's not even a number, it's a concept. Okay? It goes on forever. So you can't reach it. So anytime you have an infinity or a negative infinity, can you put an equal sign there? No, because you can never equal infinity. You can't count to infinity. Okay? What kind of dot do I have at 4? Close, so I'm going to put a equal to. Okay, whenever we're doing our domain and range for these continuous functions, or these continuous graphs, what we are doing is we are bounding where our graph is. We're saying it starts here, stops here. Okay? If we have an infinity, is that really a bound? Is that a starting or stopping point if it goes on forever? No, so you don't really have to include the infinity in your answer. Okay? Is this an acceptable way to write it? Yes, you can see it like this. But also, another way you could write it is I don't have the infinity. I just have one bound. It has to be less than or equal to 4. So I also could just write x is less than or equal to 4. Both of these are acceptable answers. Okay? Again, when we are doing our continuous graphs, domain and range, we are saying what are the lower bound and upper bound. What's the smallest value and the largest value? It's in between. Well, if it doesn't have a lower bound because it's infinity, negative infinity, it goes on forever, I don't have to state the lower bound. Okay? We okay with that? Okay, let's do our range. Range is what? Y. Draw a line at the bottom. There's where my graph starts. What's that y value? 0. Then draw a line at the top. But what do I see up here? Anytime I see an arrow, I put infinity. Now, the 0's on bottom, the infinity is on top. So is that a positive or negative infinity? If it's on top. Positive, because it's the one above, so that's the bigger one. So is it okay that that arrow represents both a negative and a positive infinity? Yes, because I have a negative x value, but a positive y value. That's allowed. That puts you in the second quadrant, which is where I am. Okay? So let's write our range. We go small to big. So 0 is less than y is less than infinity. Am I going to put an equal to on my 0? What kind of dot do I have at 0? Close, so should I put an equal to there? Yes. Can you ever equal infinity? No. Okay, so that's correct. Now, let's talk about the other way to write it without having the infinity. It would be like that. But guys, we talked about this last unit. Would you ever want your variable on the right when you're doing an inequality? No, so I wouldn't write 0 is less than or equal to y. I would write y is equal to 0. I would flip it. If I flip the number in the variable, you have to flip the inequality sign as well. So this is saying all my y values have to be bigger or equal to 0. Does my whole graph exist where y values are positive? Above 0? Yeah? Y'all are doing good, guys. This is the hardest part of today, okay? The next part, after we do our graphs, are going to be easy. Okay, is this graph a function? No, why not? It fails the vertical line test. I can draw a line right here and it hits twice. So no, because it fails. I spelled fails wrong. The VL test. So domain is x. X is your side to side, your horizontal. We awake, Yusra? Okay, side to side. So let's go all the way to the left. Here's the left. What's that x value? 0. Go all the way to the right. And what do I see on the right? Arrows. So what does that mean? Infinity. If it's on the right, are those positive or negative infinity? Positive, because it's on the right. Okay? So I would do 0 is less than x is less than infinity. You don't have a closed dot at 0, but does my graph actually get to 0? Right here, does my graph exist right there, guys? Yeah. Okay, so should I include 0? Yeah. Can you ever include infinity? No, so that's one way to write it, but again, we said you don't have to write it with the infinity. So if I get rid of that, what would be another way to write my domain? But remember, we always want our variable on the left. X is greater than or equal to 0. Very good. Do you need to know what both of these mean, guys? Yes, because you can see it both ways. Okay? Now let's look at our range. Range is y. So down here I see an arrow, so that's infinity. Is it on the bottom or the top? That's the bottom line. So if it's on the bottom, I should put a negative. Then up here, I also see an arrow. So what's that mean? Infinity. And is it on the top or bottom? So it's a positive. So I'm going to do negative infinity is less than y is less than positive infinity. So if y can be anything from negative infinity to positive infinity, is there any restriction on what your y or your range values can be? No. So that means it can be all real numbers. That's another way you can write it, all real numbers. There's no restriction on what it can be. Okay, there's a symbol we use for all real numbers. Two vertical lines to make an uppercase R. So it's an uppercase R with the two vertical lines. This symbol means all real numbers. Okay? So remember, discrete graphs are dots, continuous graphs are connected. We list out with our curly brackets our domain and range for our discrete graphs. We use our inequalities when we are doing our continuous graphs. Okay? So, is this graph a function? Why? Passes the vertical line test. Is this discrete or continuous? Why? Because it's connected. So when we do our continuous graphs, domain and range, how do we do it? When we do a continuous graph, guys, what do we use? The inequalities. So draw your line at the left. What's that mean? Infinity. Draw your line at the right. What does this mean? Infinity. This infinity is on the left, so it shouldn't be positive. It should be negative, and domain means x. So negative infinity less than x less than positive infinity. So if there's no restriction on what your x or your domain is, what else can I say? And I'm lazy / efficient, so I'm just going to use my double-lined uppercase R for all real numbers. Again, both of these are acceptable. Okay? Now let's do our range. Range is y. Y is vertical, up and down. Find the bottom. Where's this bottom line? -5. And then the top, I see arrows, which mean what? Should it be a positive or negative infinity? Positive, because it's the one on top. Small to big, bottom to top. So -5 is less than y is less than infinity. Does my graph actually get down here to where y is -5? Yeah, so I'm going to include it. Is there another way to write this? Because I don't need the infinity, so how could I write it without the infinity? Y is what?
Y is greater than or equal to -5.
Very good. Good? Next, is this discrete or continuous? Discrete. How do we know it's discrete, guys? Discrete dots. Very good. Discrete dots. Discrete dots. Is this a function? No. Okay. So, how do we do our domain and range from a discrete function? A discrete graph. This isn't a function. A discrete graph. Write them out small to big, but before I can write them out, I need to do what with my points? Write out the ordered pairs. What's this ordered pair? -1, 4. -1, 1. -1. -2. So do we see why this is not a function? X equals -1 3 times. Not allowed to have the same x value multiple times. Okay, then this one's 1, 4, 3, 4, 3, 1, 3, -2, and 1, -2. So again, we list them out, use your curly brackets, domain are x's. So I have x values of -1. Am I going to write it multiple times? No, just. Then I have x values of 1. Do I write it multiple times? No, just once. And then I have x values of 3. Do I write it multiple times? Just once. Good? Okay, next, range. Range is what? Y. I should put y and x above these. Okay. So what's my bottom y values? -2, then 1, then 4. Make sure you put your curly bracket at the beginning and the end. Okay. Good? Discrete or continuous, guys? Discrete. Is this a function? Yes, no repeat x's. Okay, domain is your x's. We need to write out our ordered pairs first, though. This one over here is -9. 1, 2, 3, 4, 5, 6, 7. -7. This one's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. -5. What's this ordered pair, guys? 3, 0. You go side before you go up and down. What's this ordered pair? -2, 2. Because we went left, left is negative. And then what's this ordered pair? Very good. So my x's. What's my smallest x value? Then? What? You skipped one. The x values? -2, then 3, then. Very good. Now do your y's. What's your smallest y value or range value? Smaller. Yep. Then 0. Very good. Good. Next one, is this a function? No, draw a line right here and it hits twice, so no, because it fails the VL test. Is this discrete or continuous? Continuous. What is my domain? Domain is x. How do we do our domain and range for continuous graphs? Inequalities. So draw a line at the far left. What's the far left number at? -4. Draw a line at the far right. What's that at? -2. So -4 is less than x is less than -2. What kind of dot should I have at -4? So do I put the equal to? No. Do I put the equal to for -2? Does it actually get there? Yeah. So put the equal to. Range is y. Where's the bottom? -4. Where's the top? 4. So -4 is less than y is less than 4. What kind of dot do I have at -4? What kind of dot do I have at 4? So do I put equal to's on either? No. So we're done. Okay? Guys, we are going to be